Hi, and welcome to another Biomedical Engineers TV video. In this video, we will look into DEXA scanners. Yes, this is the same machine which you have seen in the movie In Pursuit of Happiness, where Will Smith carries all around the movie. So where it all began. The technology and the science of two-dimensional measurement of bone mass was pioneered by two men of genius and vision, Dr. Richard Cameron and Dr. Richard Mazis. The genius of their engineering fostered the use of the concept of dual-energy X-ray delivery methods to better discriminate between soft tissues from bone and thereby enhance the direct bone edge measurement. The physics of dual energy as opposed to single-energy photon sources in principle is where two different energy sources, 30 to 50 kiloelectron volt and N70 kiloelectron volt, allow greater discrimination, soft tissue, and enhanced bone edge detection, and was a major advancement in the accuracy as well as precision of dual-energy X-ray absorptiometry, or DEXA. What is a DEXA scan? A DEXA scanner is a machine that produces two X-ray beams. One is high energy and the other is low energy. The machine measures the amount of X-rays that pass through the bone from each beam. This will vary depending on how thick the bone is. Based on the difference between the two beams, your doctor can measure your bone density. Testing your bone density, how strong your bones are, is the only way to know for sure if you have osteoporosis. The most widely used is a scan called dual-energy X-ray absorptiometry. The test determines bone health and your risk of fracture due to osteoporosis. DEXA scanning focuses on two main areas, the hip and the spine. If you can't test those, you can get a DEXA scan on your forearm. These areas can give your doctor a good idea of whether you're likely to get fractures in other bones in your body. How dual-energy X-ray absorptiometry works. DEXA works by measuring the absorbency of two X-ray energy spectra by the product. Two linear scanning arrays of pixels, each sensitive to a different range of the X-ray spectrum, detect X-ray passing through the product, producing one dimension in the resulting images. Successive scans of product moving through the scanner produce the other dimension. This simultaneously generates two 2D images. One captures the lower energy spectrum absorbency of the product. The other captures the higher energy spectrum absorbency of the product. Image processing algorithms calculate the relative ratio of energy absorbed by the product at the corresponding pixels in each image, which determines an average atomic composition at that location in the product. Let's look into types of DEXA scanners. There are two types of DEXA equipment, a central device and a peripheral device. Most of the devices used for DEXA are central devices, which are used to measure bone density in the hip and spine. They are usually located in hospitals' radiology departments. Central devices have a large, flat table and an arm suspended overhead. Peripheral devices measure bone density in the wrist, heel, or finger, and are often available in orthopedic clinics and on mobile health vans in the community. The PDXA devices are smaller than the central DEXA devices, weighing only about 60 pounds. They may have a portable box-like structure with a space for the foot or forearm to be placed for imaging. Other portable technologies, such as specially designed ultrasound machines, are also sometimes used for screening. However, central DEXA is the standard technique. Let's look into the components of a DEXA scanner. The major components of a DEXA scanner: a scanning C-arm, detector array, scanning bed, X-ray generators, DEXA operation console. Let's understand all components in a simplified manner. There are three key components to an X-ray inspection system: an X-ray generator, a detector, and a computer. The X-ray beam is generated by an X-ray tube encased in the X-ray generator. It leaves via an exit window and travels in a straight line through a collimator, a device for narrowing the stream of X-rays to a smaller fan beam. The X-ray beam then passes through the product or pack being inspected before finally reaching the detector. The second component is the X-ray generator. The X-ray generator contains an X-ray tube which generates an X-ray beam. Modern X-ray tubes consist of a glass envelope, a filament cathode, a copper anode, and a tungsten target. The cathode, which is the source of the electrons, is a tungsten filament heated to incandescence by an electrical current. The electrons are accelerated to the target by applying a high voltage between the anode and the cathode. When the electrons hit the tungsten target mounted inside the copper anode, they decelerate rapidly, and this deceleration creates the X-ray emissions. Depending on the application, different X-ray tubes can be selected to optimize the sensitivity of detection and overall performance. The third component is X-ray beams. Choosing the right collimator system is fundamental to the success of X-ray inspection, as systems can't optimally detect foreign bodies unless each element from beam angle to reject collimator mechanism has been chosen to best fit the application. Most X-ray systems use a vertical X-ray beam from the generator to scan the product as it passes through the X-ray system. The fourth component is DEXA Operation Console. An X-ray inspection system is essentially a scanning device. When a product passes through the system at a constant speed, the X-ray detector captures a grayscale image of the product, which is generated by measuring the amount of X-ray energy reaching the detector. Each image is made up of pixels, and the X-ray energy absorbed by each pixel creates a value on a grayscale, from black 0 to white 255. As the product or pack passes over the detector, each line of gray level data is added to previous lines, much like slices of bread can be added to form a loaf, resulting in a complete product image. Software within the X-ray system analyzes the image and compares it to a predetermined acceptance standard. On the basis of this comparison, the system either accepts or rejects the image and the product pack it represents. And in the case of rejection, software sends a signal to an automatic reject system, which then removes product from the production line. This was a simplified video on DEXA scanners. If you like this video, please give us a thumbs up and subscribe down below. Thanks for watching, and I will see you guys in the next video.